In this video, we're going to be doing the June 2015 Algebra 1 Regents. We're going to do questions 1 through 12. Okay, so number 1 says, the cost of airing a commercial on television is modeled by the function C of n equals 110 times n plus 900, where n is the number of times the commercial is aired. Based on this model, which statement is true? With questions like this, I like to look at the function itself first. So we know that when it's times a variable, this is 110 per something, and that should be told in the context of the problem. It says n is the number of times the commercial is aired. So $110 per airing. There we go, right? And we know that $900 is a one-time fee because there is no variable with it. Okay, so let's see what matches that. The commercial costs $0 to produce and 110 per airing. 110 per airing is good, but the 900 piece isn't. 2, the commercial costs 110 to produce and 900 each time. Well, no, it's not 900, it's 110, so the numbers are flipped around. 3, the commercial costs 900 to produce and 110 each time the commercial is aired. Sounds like it's going to be 3, but let's check the other one. The commercial costs $1,010 to produce. Okay, so it's not going to be 1,010 because it cannot air an unlimited amount of times. So it's going to be 3. 900 to produce, 110 each airing. Number 2. The graph below represents a jogger's speed during her 20-minute jog around her neighborhood. Which statement best describes what the jogger was doing during the 9 to 12-minute interval of her jog? So first, let's find the 9 to 12 interval job. So as you can see on the x-axis where we have time, we're counting by 1. It may be skipping, but it's still counting by 1. Nope, I did that wrong. 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, I'm going to stop it there. So the 9 to 12-minute interval is going to be between these green lines that I'm drawing. And if you notice, between this interval, this is a flat line, right? It's flat. And the y-axis is representing speed. So since this line is flat, this is telling us that speed is not changing. So her speed is not changing. It's the same speed between minutes 9 and 12. So let's see which one matches that. Number 1 says she was standing still. That would be if her speed was 0. Her speed is standing still at 6. So she can't be standing still. She was increasing her speed. Well, we just said it's not changing. So she can't be increasing. She also can't be decreasing her speed. So she was just jogging at a constant rate. 4. All right, number 3. If the area of a rectangle is expressed as x to the 4th minus 9y squared, then the product of the length and the width of the rectangle could be expressed as. Okay, so here they're hoping, so you know, when you have a rectangle, so we're going to say like this is the area on the inside. So what could we multiply on the top and on the side to get that? And all of our answers are a binomial times a binomial. So what they're actually hoping that you notice with this is that x to the fourth is a perfect square. They're hoping you notice 9y squared is also a perfect square, meaning, and we're subtracting, right? So they're hoping that you realize this is the difference of perfect squares. And that's telling because when you factor the difference of perfect squares, it's always going to look like that, like the two binomials. And you're going to take the square root of the first term. So the square root of x to the fourth is x squared. Because x squared times x squared, you add the exponents and you get x to the fourth. So that's x squared. The square root of 9y squared, well, the square root of 9 is 3, and the square root of y squared is just y. And once you factor it like that, you just do plus minus. You could also do minus plus, same thing, just the signs have to be different. And now we can see which one matches this. It looks like 2, because we have x squared minus 3y and x squared plus 3y. Okay, question number 4, which table represents a function? So we know a function is when every x has only one y. And a trick for this is that the x's cannot repeat. Okay, so if we look at option number 1, we see 4 appears twice in the x, and 4 has a y value, or sometimes they write it as f of x, that's okay. So 4 has a y value of 5. 4 also has a y value of 9. So the x value of 4 has 2 y values. So it cannot be 1. Okay, in option number 2, we have repeated x values with different y values. Cannot be 2. In number 3, our x values do not repeat at all. 3, 5, 7, 9. So our answer is going to be 3. And just to disprove 4 more, 0 in the x value repeats with different y values. So 3 was our answer. Number 5, which inequality is represented in the graph below? So before I even look at the options, I can see that this is shaded up. It's above this line. So this is going to be y is greater than. It has to be greater than because we're shading above the line. I also see that this is a solid line, right? So I know it has to be equal to. When you have a solid line, like that pink line I just drew, it's going to be less than or equal to or greater than or equal to, depending on which side it's shaded. And if it's a dotted line, like the one I just drew below it, it's going to be less than or greater than, not equal to. And then it's going to be less than or greater than depending on what side of the line is shaded. So this is shaded above the line, so it's greater. The black line is solid, so it's going to be equal to. And let's see if any of our options match that before we continue. So we see options 1 and 3 have y is greater than or equal to. So 2 and 4 are gone because those are less than or equal to. Now we just need to decide, is this negative 3x plus 4 or negative 4x minus 3? So what I would look for here is where the line crosses the y-axis. And it crosses at 4, making 4 our y-intercept. So we should be adding 4 at the end, and our answer is 1. Question 6. Mo's farm stand sold a total of 165 pounds of apples and peaches. She sold apples for $1.75 per pound and peaches for $2.50 per pound. If she made $337.50, how many pounds of peaches did she sell? Okay, so we know in total, most farm stands sold 165 pounds of apples and peaches, right? But we don't know, so we know in total that's the number of pounds, but we don't know the pounds of apples and we don't know the pounds of peaches. Remember, when we don't know something, we should be defining our variables. So here we should say let A equal the pounds of apples sold, and we can let P equals the pounds of peaches. Uh-oh. Okay, so now that we have defined our variables, we can write a system of equations, or we can write some functions to represent the situation and solve. So we know that the total amount of apples and peaches, A plus P, is going to equal 165 pounds. We also know that she sold the apples for $175 per pound. So that's going to be 175 times A plus. She sold the peaches for $2.50 per pound. So that's going to be 250 P. And that's going to equal the total of 337.50. And now that we have our systems of equations, we can solve. So the first thing that we can do is solve our top equation for one variable. So if we do A plus P equals 165, and we subtract A on both sides, we get P equals 165 minus A. And now that's helpful. Let me make some space because we can now substitute this P into P where the variable is. So let's see, we got 175 A plus 250 times P, but we just determined that P is 165 minus A. I'm kind of running out of space, but that equals 337 and 50 cents. Okay, so let's continue. So we bring 175A down, and now we must distribute. I'm going to use my graphing calculator for that just to ensure that I don't make any mistakes with my multiplication. So 250 times 165. So we get plus 412.5 minus 250A equals 337.50. And now we can see we actually have some like terms here. So I'm going to do 175 minus 250. And I'm subtracting because 250 is negative. And I get 0.75A plus 412.5 equals 337.50. Okay, we're going to do 337.50 minus 412.5. That was negative 0.5, my bad. So now we have negative 0.75A. I subtracted 412.5 on both sides. And I got negative 75. Divide both sides by negative 0.75. We got A equals 100. So we know how many pounds of apples she sold. She sold 100 pounds of apples. But we're not looking for apples, we're looking for peaches. So if she sold 100 pounds of apples, and it was 165 in total, we know she sold 65 pounds of peaches. Because 100 pounds of apples plus 65 pounds of peaches equals 165. Oof, okay. Question number 7. Morgan can start wrestling at age 5 in Division 1. He remains in that division until his next odd birthday, when he is required to move up to the next division level. Which graph correctly represents this information? Okay, so it appears that this graph, the graph itself is the same in all 4 answer choices. The only thing that is changing is if the dots or the endpoints are closed circles or open circles. So let's review what those mean. A closed circle is included or equal, right? So if there is a closed circle, that means that that is equal to that number at that point. An open circle means not included or not equal. Okay? So immediately looking at 3, when you see options like this where you have, see how we have 2 closed circles on the same x value? We immediately know that this one is wrong because at age 7, for example, Morgan cannot be in Division 1 and 2. At age 9, Morgan cannot be in Division 2 and 3. He just can't be in the same division, 2 different divisions at the same time. So it's not 3. Similarly, we know 4 cannot be the answer because here we have open circles, 2 open circles at the same point. And we know this can't be true because at age 7, Morgan is not in no division, right? So he's either going to be in one division or the other. So at age 7, he's either going to be in Division 1 or Division 2. Not in both like in option 3, and not in neither like in option 4. So it can't be 4. So now we just have to decide if it's option 1 or option 2. Well, let's go back to the question. The question says he remains in that division until his next odd birthday. Meaning that on his newest odd birthday, he gets bumped up a level. So let's look at option choice 2 really quick. This is saying once he passes age 5, right, he starts wrestling at the age of 5. And while he's 5, 6, and then finally 7, right, so during that whole age frame, he's going to be in Division 1. But the minute he turns 7, he's going to get bumped up. And graph number 2 is saying that Morgan is still in Division 1 on his 7th birthday, and then later on moves to Division 2. Graph 1 is saying, so we have on his 5th birthday he starts, closed circle. From 5 to 6 and on, he stays in Division 1, but then immediately once he turns 7, he bumps up. He's in Division 2 now. He stays in Division 2 while he's 8, and then he gets to his 9th birthday and immediately bumps up. Because of this, our answer choice is going to be 1. Okay, question number 8. Which statement is not always true? Okay, so we have the sum of two rational numbers is rational. The product of two irrational numbers is rational. The sum of a rational and an irrational is irrational. And the product of non-zero rational numbers and an irrational number is irrational. So here, it's going to be helpful to know the rules when we're adding and subtracting rational and irrational numbers. Basically, the rules for both are going to be the same. So if you have rational and rational, it's going to be rational. Rational and irrational, or irrational and rational, are both going to be irrational. The only one that is not always the same is going to be irrational and irrational, and this is just going to be sometimes irrational. And now this is going to work, so I'm going to erase these little lines. This is going to work whether we are adding, so if we're finding the sum, or if we're multiplying or finding the product. So the only one that's talking about two irrationals is option 2. So that is not always true. It's sometimes irrational, but it's sometimes rational. So not always. Okay, question 9. The graph of the function f of x equals the square root of x plus 4 is shown below. All right, let's jump into our graphing calculator for this. So we got y equals, we're going to put the square root in. So second x squared brings up the square root sign, x plus 4. And let's look at the graph to make sure that that is correct. So it is. And now let's go into our table. So if we look at our table, let's go up. So once we get lower than -4, there are no x values that produce a y value. As you can see, the table is telling us we have an error. So that can be a little bit helpful when we're looking at domain, because remember the domain is the x values. So we know we cannot include any x values less than -4 because the table tells us we have an error. And looking at the graph, lower than -4, there is no graph of a function. So the only x values that we care about is when they are greater than, right? And greater than what, right? Greater than wherever this starts, which is -4. So we know because of that, we can get rid of option 1 and 2, because that says greater than 0. Now, is it greater than or equal to? Similar to the last question, we got to look at our endpoint. It is a closed circle, so that means it's equal to, and it's option 4. All right, question 10. What are the zeros of this function? This is going to be another graphing calculator one, at least one way to do it. So put an x squared minus 13x minus 30. Second graph. And we're going to look for where y is 0. So y is 0 at -2. And only one of these answers has -2 as an answer. So our answer is 4. If you wanted to do this by factoring as well, you could find the numbers that multiply to -30 and add to -13. In this case, that's going to be -15 times 2, because that equals -30, and -15 plus 2 equals -13. So because of that, we can write x minus 15 and x plus 2, set it equal to 0, and now solve each one for 0. X minus 15 equals 0, add 15 to both sides, and you get x is 15. x plus 2 equals 0. Subtract 2 from both sides. You get x equals -2. So whichever method you prefer. Question 11. Joey enlarged a 3-inch by 5-inch photograph on a copy machine. He enlarged it 4 times. The table below shows the area of the photograph after each enlargement. What is the average rate of change of the area from the original photograph to the 4th enlargement? Okay, so it's asking about rate of change. So it might be helpful for us to remember the formula here. So we know that the rate of change formula is the change in y divided by the change in x. So delta y divided by delta x, or many of you may have seen this as y2 minus y1 divided by x2 minus x1. And now we have to pull these points out. So we want to know the average rate of change from the area of the original. So the original is going to be 0, 15. To the 4th enlargement, which is going to be 4, 36.6. So this means that point 1 is going to be 0, 15, and point 2 is going to be 4, 36.6. And it can be helpful to label this. So for 1, that's going to be x1, y1, and for 2, that's going to be x2, y2. So we're going to subtract the y's, we're going to subtract the x's, and we're going to divide. So let's start with y2. We got 36.6 minus 15. And that's going to be divided by 4 minus 0. Okay, and 36.6 minus 15 is 21.6. So we get 21.6. 4 minus 0 is 4. And 21.6 divided by 4 is 5.4. Answer choice 3. Okay, and question 12 will be the last one for this video. Which equations represent the graph below? Okay, so this is another potential graphing calculator question. We can put all of these into y equals and see what kind of graph comes out. What's going to be important to notice here, though, is that our zeros are at -2, +1, and +3. We need to make sure that whatever graph that we get in our graphing calculator also has those points. Another point that could be potentially useful is our y-intercept, which is up here at 6. Okay, so let's put all of these in. So option 1, we got x plus 2 and x squared minus 4x minus 12. Let's look at the graph. So as we can see here, this one definitely does not match it. Our zeros are at -3, -2, and 4, and the shape is just off. So we know it's not 1, which means the answer choice cannot be 1, and it cannot be 3. The other answer choices that we have is either 2 or 2 and 3. Either way, we know that 2 is going to be an option. So I'm going to go ahead and skip that one, and I'm just going to test 3. Okay, so x minus 1 and x squared minus 5x minus 6. Graph. Okay, as we can see, this one also does not fit the pattern. Our zeros are at -1, +1, and that looks like 6. So that is not the zeros that we have, so it cannot be 3, which means it cannot be 4, which means our answer choice is 2. Okay, the questions 13 through 24 will be in the next video. Hope this was helpful.